We're still busy looking at equivalence classes. Now in the topic of relations, we looked at what a relation is. We looked at some properties of relations, reflexivity, transitivity, and some metric relations. Then we said we've got an equivalence relation if a relation is reflexive, symmetric, and transitive. And then in the previous video, we looked at equivalence classes for some of these equivalence relations. And we're going to continue to look at more examples of how to generate these equivalence classes. All right, so in a previous video, we've shown that this relation R we have there on a set of ordered pairs, this relation is an equivalence relation. So we know it's reflexive, it's symmetric, and it's transitive. But now we're looking at equivalence classes. So if I want to look at an equivalence class, just to remind you for this example, but in general, equivalence class is a set of all those elements from the set I'm looking at that has this relation with that xy or whatever the equivalence class of that I want to take. So the equivalence class of xy will be all ordered pairs AB such that this relation holds. So such that xy are AB. So for that to be true, so it's all the ABs that match up with xy with this relation. If we want to be more specific with this definition, we've got it's all the ABs given xb is equal to ya. So it's all the ordered pairs for which that is true. Now when we look at it like that, it's a bit difficult to generate, and we want to get a way to generate these ordered pairs, to generate this equivalence classes. So let's look at a specific example, because that'll be easier to look at. So if I look at the ordered pair 1, 2, that's an element of A. So the equivalence class of that will be all the ordered pairs AB given xb is equal to ya. So 1 times b I can write 1 times b is equal to 2a. All right, so what do I know about these a's and b's? We must just be so specific so that we don't lose this fact, because that b value can't be 0. So we know a is any integer, but b is an integer except 0. All right, but now a and b is now linked all of a sudden. So we're going to, let's see how we're going to do this. This is the set of all, well, b is the same as 2a. So every time b must be 2a, so b must be double a. So what I've got is if I choose a, b is then just going to be 2a. And that's easier to have everything with one variable. So a is my variable. But then what do I know about the value of a? So a must then be from the integers without 0. So a also can't be 0, because a and b are now linked. So what would it look like if I generate this set? Well, now, how many elements will this set have? An infinite number. But let's just look at some of them. Well, we start choosing a and calculating b. Now, a can't be 0. But what if a is 1? And I'm leaving a gap here. You'll see why. If a is 1, b is going to be 2. If a is 2, b is 4. And so on. But in the other direction, a can't be 0, but a can be minus 1, and then b is minus 2. A can be minus 2, then b is minus 4 in that direction. So I've got the dot, dot, dot in both directions because this set just keeps growing. But this is what it looks like. So there's an infinite number of elements of this set. So this is the equivalence class of 1, 2. Now don't forget what we're doing. Once I have an element of the equivalence class of 1, 2, it must work, meaning this must be true. So if I look at minus 2 minus 4, then x, so 1 times minus 4 must give me 2 times minus 2, and it works. All right, so that works for all the elements. But this is a structured way to generate the equivalence class, rather than trial and error and guessing. Right, now this was a nice one. But what happens when the numbers don't work out that nicely? So let's generate the equivalence class 3, 4 for the same equivalence relation. 3, 4. So that is the set of all ABs given, let's just check, xb must be equal to ya. So 3b must be equal to 4a. And what do I know about a and b? Well, a is an integer, and b is from the integers except 0. All right, we're going to refine this shortly. It's going to get more specific. Because now to generate numbers where a and b work, what we need to do, what have we got here? So this is the set. 3b is going to be equal to 4a. So it's all the ab's. Now, what will the value of b then be? Let's get it all in terms of a. b is 4a divided by 3. All right, now we've got to watch out. Now we've got a fraction here, but all our values are integers. So we've got to watch out for that one. But we'll see how to work this out, where a is an integer and b is an integer, but not 0. All right, so let's get this better. If I've got the b value is equal to 4a over 3, then I've got the set of all a's and 4a over 3. So I eliminated the b. But a then can't be any integer, can it? Well, it has to be an integer so that the b I generate also becomes an integer. So now I've got to think carefully, what do I have here then? This is still the set I've got. A can be any integer, but that 4a over 3 must also be an integer, but it can't be 0. Right, that gets a bit messy. Well, let's rewrite it then. 3a and 4a. And then a can be any integer without 0. All right, so I've just played around with it so I can get it in a format that can work, that I can generate these elements. So let's take a look. And we always have to test at the end. If a is equal to 1, I've got 3 and 4. If a is equal to 2, I've got 6 and 8. If a is equal to minus 1, I've got minus 3, minus 4. If a is minus 2, I've got minus 6, minus 8. And in both directions, it just keeps going. So let's just test one of them. Minus 6, minus 8, 3, 4. Does it work? Well, 3 times minus 8 must be the same as 4 times minus 6. I've got minus 24, minus 24. It works for that one. So we had to play around a little bit so that we can get it in a format. So this format I've got here is the easiest way to generate the elements, because else we're going to have to use trial and error. So that's what my set looks like. So there we go. That's generating elements and writing an equivalence class for a specific element. So just take note, the two equivalence classes looked different because it depends on what element I am looking for.